At your desk with the people around you for like 2-3 minutes, and then we'll go over them as a class. So work on those 2 problems for a few minutes.
Sorry.
I don't got warm up.
Yeah, you do. It's on page 18.
I don't have notes.
Where are your notes? Oh,
I think they're in there.
that's
That's a good question, though.
But you have them somewhere.
Where are we
But
at?
try to do this algebra problem, and then the number 2 is more geometry.
Hey, where is he at? You said what number of notes?
Page 18.
Okay, found it.
I want you to try these ones, Jordan, and then if you need my copy after, I'll give it to you. I just don't have it all.
I got this.
You got it? Okay. Yeah, grab a calculator if you need one. No worries.
Page 18.
Page 18 is where we're at.
How do we find X?
Combine like terms on both sides, simplify both
Okay,
sides.
okay, okay.
Why did you give me all these? Thank you.
What's 1/3 of 4? 1.25?
1/3 times 4,
Yeah.
4/3.
Uh,
Yeah, it's like 1.33333. Repeatedly.
What the hell are you talking about, dude?
Page 18. Try to do these 2 problems. I know the first one might be scary because there's fractions. Also, I talked about the cheat sheet with you guys, right? If you would like your copy now to have over the weekend, if you want to get started on it, raise your hand. I can give it to you now. If not, you can just get it on Monday. No worries. But raise your hand if you want it now. Yeah, Charlie, you were not here. You can use this piece of paper and you can write anything you want on it on your test, for your test. Cheat sheet. Who else wanted one right now? Cheat sheet.
I could.
Boom. Anyone else want one right now? Want one? And again, on probably Monday or Wednesday, I'll talk more about what I would recommend putting on there, things that you should probably definitely have. But if you want to start it on the weekend, you can.
I don't got a, 1 over button on my app.
Just put in parentheses and do 1 divided by whatever number. And just enclose it with parentheses. All right, let's finish these out together because I'm going to show you a trick on the first one. Raise your hand if you hate dealing with fractions. That's what I figured. There's a way that we don't even have to deal with this 1/3.
You gotta multiply.
What number could I multiply this 1/3 by to
3.
get rid of it? 3. So I'm going to multiply both sides of my equation by 3. And some magic's going to happen. My 1/3 turns into a 3 over 3, which is just 1. So my 3's cancel. I'm left with 1 times x minus 4. The reason the 3 doesn't get brought into here as well as the 1/3 is because it's all multiplication. We're only multiplying this in one time to either of these pieces, not to both, because there's multiplication here. If there was like a plus sign in there, then we would have to distribute it all out. And then on the right-hand side is when I distribute, 3 times 2x is 6x, and then minus 3. Is this 1 doing anything right now?
Nope.
Nah.
So you gotta distribute.
Get rid of it or distribute it, whatever. You're left with x minus 4. What's up?
None.
You good?
Yeah.
Don't throw it. Don't do it. Okay.
So you
I'll do
gotta add 2. Wait.
Okay, yeah, what should we do with this x?
Plus 4.
Sure, we can add 4 and subtract 6x. Or that way, Charlie, that works too. X minus 6x is negative 5x. And negative 3 plus 4 is positive 1.
So you divide.
We divide, and our final answer?
X equals
Negative 1 over 5.
I got
Questions on that
How
one?
do I get negative 0.2?
I got that first too. You gotta put everything in parentheses.
Negative 0.2 is good. That's 1 over 5.
Alright.
That's the same thing.
Oh, I'm just.
So can I put
0.25
0.2?
is 1 over 4.
Yeah.
0.2 is good. Negative 0.2.
Okay.
That works.
Alright.
Any other questions on this one? Just algebra. I know we need some practice with it sometimes. That's all right. Let's do the next one. Next one's geometry, and kind of similar to that one, the very last other problem that you just did. It says this angle is a straight angle, and we need to find the measure of each piece of it. Go ahead. Thanks, bud. What's the measure of a straight angle? I see this math word. What does it tell me?
180.
180. So this entire angle is 180 degrees. What's equal to that 180? What should I do with the other two things there?
Divide.
Not divide.
Oh, you gotta add.
Add them and set them equal to 180. That was our angle addition postulate. Part plus part is equal to the whole thing.
But first, gotta find X.
Yeah, that's how we're going to find x. So 10x minus 5 plus 4x plus 3 is equal to 180. That's fine. Yeah, we can do it like this for sure. If you want to keep them a little separated at first to see where you're getting those things, not a bad idea. And then we combine like terms. What's 10x plus 4x?
14.
14x, perfect. Negative 5 plus 3. Negative 2. So we get 14x minus 2. We're still solving for x. What should I do to move that 2 over? Add 2 to both sides. We get 182 is equal to 14x. And then we divide. 182 divided by 14 is 13. So x is 13. But did the question ask for x? No, it asked for the angle measure. So which of these expressions, the 10x or the 4x, should we plug x into to get KLN? Hold on, to get KLN. If we wanted KLN.
Oh, then 10x.
The 10x minus 5. Okay, so the measure of angle KLN is equal to 10 times x, 10 times 13,
125.
minus 5, we get 125. Perfect. Okay. I could plug x in to this piece and get this angle measure. I'm going to do it without plugging x in. Does anyone know how I would find this angle measure without dealing with x at all? Subtract them, yeah. We could do the measure of the other small angle, NLM, is equal to the entire angle, the whole thing, 180, minus the piece we already found, minus 125. Yep, we would get 55 degrees.
And that goes to both of them.
Not to both of them. It's not a bisection here. They're not
Oh,
congruent.
Yeah,
Yeah, it's just addition. So 125 and 55. Questions on the warm-up? Okay, there are three definitions today, and if you know those 3 definitions, you will ace this part of your test, okay? You need to know 3 words and what they mean today. The first one is complementary. 2 angles are complementary if you take their measures, you add them up, and you get 90 degrees. So 2 angles are complementary if they add to 90 degrees. Someone give me a random number less than 90. Less than 90. Huh?
4. 4.
4. Okay, so I could have a 4-degree angle. What would the measure of its complement, aka the angle that's complementary to it, be? 86. A 4-degree angle and an 86-degree angle are complementary. They might look like this. They might be nowhere near each other. Or they could also kind of fit nicely in a right angle. This is a special type of complementary angles, which we'll talk about in the second part of this. But any two angles that add to 90 degrees are complementary. What are you doing, Jordan?
He just grasped his hair.
Okay, that's
Sorry,
actually
leave it
a
out.
good friend. Okay.
Yeah, stop barking at me.
So,
He's scared.
Stop burping.
Okay.
Get in class.
reel it back in.
What?
So, if we see the word, listen, if we see the word complementary or complement, you think 90 degrees, add to 90. If you see the word supplementary, I want you to think of 180. Supplementary angles add to 180 degrees. So complementary 90, supplementary 180. Same thing with supplementary. We could have them kind of together like this. We could do 120 and 60. Or they could be separate. 120, 60. So it doesn't really matter as long as their angle measures add to 180. Okay. So for this first one, we are going to name 2 complementary angles and 2 supplementary angles. So for complementary, am I looking for 2 numbers that add to 180 or to 90? 90. What 2 numbers on here add to 90? 58 and 32. So now I'm going to name those angles. Let's look at 32. If I trace it out this way, what's the name of the angle? CAB. Okay. And what's the name of the other angle? RST. So angle CAB and RST are complementary. For supplementary, what number are we looking to add to? Not 90, but 180. What 2 numbers on here add to 180? 122 and 58. Yeah, those 2 pink ones. What's the name of the pink angle on the left? CAD or DAC, perfect. What's the name of this angle? We already named it once.
RST.
RST.
So TSR.
Or TSR, perfect. We can switch it up. Why not?
Hey. Let's go.
So anytime you're identifying pairs of angles that are complementary or supplementary, you're just looking for the numbers that add to 90 or to 180. So down here,
Complementary.
we're determining if the angles are complementary, supplementary, or neither. For the first one, if I add these 2 angles, what's 30 plus 39? 69. Is that complementary, supplementary, or neither? Neither.
Jordan, you are 8 years old.
You literally just bro.
The next one, if we add these 2, what's 41 plus 49? 90. So how would we classify this pair of angles? Complementary. Complementary. And if you're confused between the 2, you can think of it as like C comes before S in the alphabet, so this one's smaller. It comes before the other number. If you're confused and need help differentiating. The very last one, what do we think? Complementary, supplementary, or neither? Supplementary, 148 plus 32 is 180. So these are supplementary. Questions on those definitions? That's about as hard as it gets today. A little bit more, but nothing crazy. So if you can handle those 2 words, you're going to be just fine today.
Oh, nah.
This next example, says angle B is a complement of angle D.
Oh,
What does complement mean? It means the two have to add to 90. And angle D is 79. So to find, listen, here's how I want you to think about it. Our 79-degree angle plus whatever angle B is has to add to 90. So, Jordan, how'd you get 11? What'd you subtract?
90 minus 79.
Perfect, 11 degrees.
Yes.
You can double check 11 plus 79 equals 90.
Girl, I didn't check.
Same thing for the next one, but now it says angle G is a supplement. Supplements have to add to, what number? 180. So I'm looking for the measure of angle G plus,
Bro.
sorry, the measure of angle H plus
It's 65.
115 equals 180. I know, I'm just writing it out so we can kind of see what's happening here.
You just threw my inhaler on the ground.
Don't throw his inhaler. And we get 65. What's the label we need? Degrees.
Right.
Questions on that one? Okay, that's your first two definitions. Complementary, 90 degrees. Supplementary, 180. There's one more definition.
Oh, adjusted angles.
Adjacent angles. Two angles are adjacent.
If they share.
A
Hold.
point.
Ooh, very, very close. Hold on. Have you guys heard the word adjacent before?
Yeah, they're like.
They're like kind of next to each other, right?
Yeah.
Kind of like, yeah, they're next to each other. So two angles are adjacent if they share a point, aka a vertex, and if they share a side. So your adjacent angles could look something like this. We are sharing this side, and here is the common vertex. So this angle right here and this angle right here are adjacent. They're right next to each other, but they don't overlap. They have to just share a side and stop right there. They don't overlap. So for these two, do we think angle 5 and 6 are adjacent?
Yeah.
Yeah, the common side that they share is this purple one. So these are adjacent angles. What about angles 7 and 8? What do we think? Adjacent or no? No, so we would say non-adjacent because they don't share a side. They're not right next to each other. And this kind of ties into supplementary and complementary. And I kind of talked about this a little earlier, but we can have both of these things at the same time. We can have adjacent and complementary, adjacent and supplementary, or non-adjacent in either of those options as well. So if we want adjacent complementary, complementary adds to 90. So what I'm going to do is I'm going to draw a 90-degree angle. And I'm going to cut it into two pieces. Because those two pieces that I just made are now adjacent. That line that I drew to cut them is their shared side. Easy, Caden.
You're trying to get it to touch the wall.
Don't.
Give you $1.
So, for example, this could be a 50-degree angle and a 40-degree angle. They would be adjacent complementary. They're next to each other and they make a right angle. For non-adjacent complementary, we can have this 50-degree angle and maybe this 40-degree angle. Not next to each other, not touching. They could touch, but they need to not share a side. What about adjacent supplementary? For complementary, I drew a 90-degree angle and I cut it. So for supplementary, I'm going to draw a 180 angle and cut it. So here's my...
Do 90-90.
Yeah, we could do 90-90.
And then do 90-90.
I'm going to do 120 and 60. Just so it's not exactly the same. But these would be adjacent and supplementary. This is their shared side. Non-adjacent and supplementary, those angles could be anywhere. So we could get something like that. Questions on adjacent angles?
No.
Okay. Let's, yeah. For the next example, we're going to skip the complementary and supplementary part. We already did that. We're just going to do the adjacent part. So, for this first one, can someone give me a ray that is a side for two different angles? GH. Not GH. GK, yeah, right here. Boom. I guess it's not a ray in this case, but you get the idea. It's a segment. So let's look at which two angles are adjacent if this purple piece is their common side. What's the name of this angle? FGK. Okay, so angle FGK. Hey, have this conversation later, Jordan. Okay. This red angle, what other angle shares its vertex and a side? What do you think? What did you say, Reagan? I agree, HGK. And it's almost even easier to see when we write it out because those two are my adjacent angles. What do these two have in common? What's the same about them? About those letters that I just wrote down?
Their endpoint is K.
Not the endpoint, but yeah, the vertex is G.
Yeah.
So they share a vertex. And one of their sides is GK. That's always going to happen for adjacent angles. They'll have the same middle letter, and then one of the other letters is going to be the same because they share a side. For the next one, can someone give me the side that two angles share?
CAB.
Yeah, AC. So angle CAB is adjacent to what angle? Here's angle CAB.
CAD.
Yeah, CAD, perfect. This red angle, CAB, and this red angle, CAD. And again, we can double check CA and CA. They have the same vertex and the same side. Questions on adjacent angles? Okay, we are almost done.
Almost.
Bear with me. We have a few more things, two more examples, and then we're done. Okay. First few things. And most of these will make sense numerically.
Apple Watch. Off
Get
my-
it off.
I know.
Off my all day.
Most of these things I'm going to talk about will make more sense when we do an example and put some numbers in. Okay? But we're going to talk about three different theorems today. A theorem is a true statement that we can prove. It's a little bit different than a postulate. Postulates we don't prove, we just kind of believe them to be true. Theorems we do prove. And I'll talk a little bit about what the proofs of these things look like, but in this class we don't worry about it too much. Caden, turn around.
Turn it down. That's
So, listen. The first theorem is that all right angles are congruent. That makes sense. What's the measure of a right angle? 90. So two right angles both measure 90. They have the same measure. Therefore, not 45. We're saying this right angle and this right angle are congruent because they have the same measure. Because they both measure 90. So, that makes sense. In this picture, angle 1 is congruent to angle 2. And the proof behind that is because measure of angle 1 equals 90 and the measure of angle 2 is 90. They're the same measure. They have to be congruent. We essentially just wrote a very short proof for that. The next two are a little bit trickier. First one is the congruent supplements theorem. And all of these theorems are technically from chapter 2, which we do next after this chapter. So we'll see them again.
Be ahead of the game.
Not necessarily. So we'll talk about these more in chapter 2, but I'm talking about them. But I'm talking about them now because we need to know them in chapter 1 as well. They honestly make more sense to be in chapter 1, but they're in chapter 2 for whatever reason. So we're talking about them now. And we will talk about them later as well. But congruent supplements theorem tells us that if two angles are supplementary to the same angle, then those two angles are congruent. For example, if I have a 50-degree angle, and I say that angle A is supplementary to that 50-degree angle, what measure of angle A would you give me? If it's supplementary.
42.
Supplementary to 50.
79.
Supplementary.
140
130. 130.
Oh, yeah,
What are we
130.
talking about?
Supplementary. Add to 180. 130 plus 50 is 180.
Oh.
So a supplementary angle, if A was supplementary, it would be 130. But then what if I told you angle B is also supplementary to that 50-degree angles? What does it have to be?
130.
130. That's why they're the same. They add to the same number to get 180, so they have to be the same. Makes sense. So here, if angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, can you tell me which two angles are congruent? 1 and 3 are both supplementary to angle 2. What do we think?
So, 1 and 3 are
They
congruent.
both add up to 90 together.
Not necessarily. What two angles have to add up to 90?
1 and 2.
1 and 2 have to add to supplementary, so 180. And 2 and 3 have to add to 180. So what do we know about angles 1 and 3?
Oh, I thought you were talking about 1 below.
Oh, no, not yet. Say it again, Jordan. You said it earlier. These two angles are
Oh, 1 and 3.
congruent, is what you said. Congruent.
Uh,
Yeah, 1 and 3. Actually, no, 1 and 3 is what you said. Yeah. Angle 1 congruent to angle 3. It's the same as this. We said these two angles are congruent because they are both supplementary to the same angle measure. So for the complementary version, the congruent complements theorem tells us that if two angles are complementary to the same angle, then they are congruent. Again, makes sense. We could do this, but with 40 degrees instead of 130, and it would look the same. So here, angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary. So which two angles are congruent?
1 and 2.
1 and 3. Because 1 and 3 are both complementary to angle 2. Questions on that one?
Is that the 2 or is that only 1?
That was 0.
What?
Are you done now?
Those are not examples. Now we start our 2 examples.
Alright, for real,
And then we're
bro.
done. Okay.
You joshing with me?
Okay. It says measure of angle 10 plus measure of angle 11 is 90 degrees. That means that angle 10 and angle 11 are what? Not congruent,
Supplement.
not supplementary, complementary. So they're complementary. And it also says, focus, it also says angle 11 and angle 12 are complementary because they add to 90. So if two angles are complementary to the same angle, to angle 11, what do we know about those two angles?
They're congruent.
They're congruent. So in this case, angle 10 is congruent to angle 11. Questions on that one? Okay. The last example is not in your notes, so I'm going to give you a second to write this down, and then I'm going to pull up a different example. We'll do it real fast, and then you'll have your homework time. This is number one.
And then I have to do another one that I have to write down, and then a third one.
No, you don't have to write it down.
3.
That's what I'm saying. You don't have to write it down. Easy peasy. So, we're going to do the first one, and then I'm going to set up the second one. You don't have to solve it, though. We're just going to look at how it's set up, because that'll at least get you started on your homework. So,
45 degree.
hold on. It says, we have the frame of a ball return net. Here's the frame of the net. And it forms a pair of supplementary angles. It's talking about BCE, so this angle, and ECD, so this angle. It says they are supplementary. I see supplementary. What number am I thinking of?
180.
180. I'm going to write it down, 180. Okay. It says those angles are supplementary. So what should I do with them to get them to equal 180? Add them. Perfect. 4x plus 8 is equal to, not equal to, sorry, 4x plus 8 plus x plus 2 is equal to 180. I would solve for x.
Subtract the 4.
Let's combine them first.
That's what I said.
So 180 is equal to 5x plus 10.
Yeah.
Now what?
Subtract 10.
Subtract 10, 170
Divide by 5.
is equal to 5x. Divide by 5, 20, 32? No. 50, 34. 34. Math, mental math. The way I did it, you ready for some more mental math tricks? I took 100 out, 100 divided by 5, 20. I took 70, 14. Boom, add them together. It's great, it's tricks. Okay, x is 34. Did the question ask me for x?
No.
No, it asked me to find B, CE, and ECD. So let's do BCE. What should I plug x into to find BCE?
4x.
4x plus 8. So 4 times 34 plus 8. I actually, 120, 136 plus 8. Don't throw that.
I'm trying to
144?
Put it away.
It's 144.
And
That's what I said, 144.
I heard 134.
I said 144. I know my mental math.
Can I toss it
All right,
so you
buddy.
can put it away?
And then the last question says find ECD. I don't even have to plug 34 in.
36.
You could, it's pretty easy to plug in, or you could take 180 minus 144.
36. 3.
And you would get 36, exactly.
Ah.
Very good.
So questions on that one. That one just had some algebra, we haven't seen that yet.
Well,
The next one,
yeah, no.
listen, it says that these two are complementary. So I should add these and set them equal to what? Complementary, 90. Okay? So, complementary, 90. Supplementary, 180. Adjacent, next to each other, sharing a side and a vertex. Questions, comments, concerns? Homework time. Try to leave today with no homework for me. This is like our second to last section. So if you finish this one and you're not missing anything, you only have one more assignment until the test. Yes.
I might have to stay.
Mhm.
I don't know it.